Did you know the sky isn't actually blue? It's invisible. We're seeing something that doesn't even have a color. And our brains are basically lying to us about what we're looking at. Wild, right? Everyone's been taught the wrong answer in school. You've probably heard the sky is blue because water is blue, but that's totally backwards. Water actually absorbs color from above. The ocean reflects the sky, not the other way around. Here's clue number 1. The sun doesn't actually emit blue light. It emits all colors mixed together, which creates white light. So if the sun doesn't send us blue light, where does the sky's blue color come from? This is the mystery. Welcome to Rayleigh scattering, the real science behind everything. When sunlight enters our atmosphere, it crashes into tiny molecules, nitrogen and oxygen. These molecules are so incredibly small compared to light waves that they scatter light in all directions randomly. Here's the critical part. Different colored light has different wave sizes. Blue light has short, tightly packed waves. Red light has long, loose waves. Short waves scatter much more easily than long waves when hitting tiny molecules. This is why blue wins the scattering race in our sky. Red light barely gets scattered and mostly passes straight through. Blue light bounces and spreads everywhere, filling the sky with blue photons heading toward your eyes from every direction above. The mathematical rule is simple. The smaller the light wave, the more it scatters. This is called Rayleigh scattering, named after the scientist who discovered it. This same process explains why smoke looks blue and why ocean horizons appear blue too. Now here's where it gets weird. Violet light scatters even more than blue. So why don't we see a purple sky? 3 reasons. The sun produces less violet light naturally, plus our eyes are less sensitive to violet, and the atmosphere absorbs most violet light before it reaches us. Here's the mind-blowing truth. You're not actually seeing blue color floating in the air. You're seeing millions and millions of scattered photons hitting your eyeballs. Your brain interprets this light scattering pattern as the color blue. The sky has no color, only light has color. Let's test this with something you've definitely experienced. Remember being underwater in a pool looking straight up? The water looks blue-green because the same scattering happens in water molecules. But the sky above the water looks even bluer because more blue light travels straight down through the atmosphere. Here's another real-world test you can try right now. Look at a sunbeam coming through a dusty window on a sunny day. The dust particles scatter light and you see the beam. That's exactly what's happening in the sky constantly, except the dust is invisible gas molecules. The sunset is the ultimate proof of how scattering works. When the sun is low on the horizon, light has to travel through much more atmosphere to reach you. All the blue light gets scattered away sideways before reaching your eyes, leaving only red and orange light to reach you directly. That stunning orange and red sunset you saw? That's not the sun's true color. It's the color left over after blue light escaped sideways through the atmosphere. It's the same sun, same light, but the journey through air has stripped away all the blue wavelengths before reaching you. Let's talk about light wavelengths more precisely. Blue light has a wavelength around 450 nanometers. That's 450 billionths of a meter. Red light is around 700 nanometers. Shorter wavelengths scatter more dramatically according to Rayleigh's formula. It's physics. Nitrogen and oxygen molecules in Earth's atmosphere are about 1 nanometer across. They're tiny compared to the wavelengths of visible light. This size difference is exactly why light scatters so effectively. Imagine a giant beach ball hitting a pebble versus a tennis ball hitting the same pebble. The size difference matters enormously. Your eyes detect specific wavelengths, and your brain translates them into colors. An alien with different eyeballs might literally see our sky as purple, green, or infrared colors we can't even imagine. We're not seeing objective reality, we're seeing our eyeballs' reaction to photons. Wild. The chemistry of air matters too. Earth's atmosphere is mostly nitrogen and oxygen, which scatter blue light perfectly. If our air were different, say, filled with different gases, the sky would be completely different colors. Mars has a butterscotch-colored sky because its atmosphere is thinner and its dust particles are larger. The intensity of light also matters. At night, the sky appears black because there's barely any scattered light reaching your eyes. During twilight, when sun is below horizon, the upper atmosphere still catches sunlight and scatters it, creating that gorgeous purple-blue glow you see after sunset. The scattering continues even when the sun disappears below the horizon. Rain creates an interesting effect with light scattering too. Raindrops are much larger than air molecules, so they scatter light differently. They create rainbows by separating white light into individual wavelengths. This is dispersion, which is actually the opposite effect of scattering. Here's something most people never notice. The sky isn't uniformly blue. It's deeper blue directly overhead and lighter blue near the horizon. This is because light traveling straight down goes through less atmosphere than light from the horizon. Less atmosphere means less scattering, so less blue light reaches you from directly overhead areas compared to the horizon. Clouds complicate things even more. Water droplets in clouds are large enough to scatter all colors of light equally, not just blue. This means clouds appear white or gray because all colors mixed together create white light. The scattered blue light and scattered red light and everything else all reach your eyes together. Pollution and air quality affect sky color too. In heavily polluted cities, the sky often appears grayish-brown instead of blue because larger dust and particle pollution scatters longer wavelengths. This shows that the sky's color directly depends on what's floating in the air above us. High altitude actually changes what you see. At the top of mountains, the sky appears darker blue because there's less atmosphere above you doing scattering. In space, the sky appears completely black even during daytime because there's no atmosphere at all to scatter sunlight. Astronauts see a black void, no blue sky. The ocean appears blue for a completely different reason that people get confused about. Water itself slightly absorbs red wavelengths more than blue wavelengths, but mostly the ocean reflects the sky, so the ocean looks blue because the sky is blue. The ocean is basically a giant mirror of the sky's scattering light. Here's the crazy part. Scientists can calculate sky color mathematically. They use equations involving wavelength and particle size. You can predict what color the sky will be on any planet with any atmosphere composition using physics formulas. The universe follows rules, even invisible ones. So here's the ultimate truth. Asking, why is the sky blue, is actually asking, why do my eyes interpret scattered photons as the color blue? The sky isn't blue. Light isn't blue. Wavelengths aren't blue. Blue is just your brain's way of interpreting light energy. The sky is invisible. We're just looking at our own perception. The beautiful thing about this is how it connects physics, biology, and perception. It's not just the sky is blue, it's a story about light, molecules, wavelengths, and how our brains work. Every single day, you're witnessing Rayleigh scattering without even knowing it. The universe is incredible. Next time someone asks you why the sky is blue, here's your answer. The sky isn't blue. Scattered photons from sunlight hit air molecules, and my brain interprets the scattered blue wavelengths as the color blue. Plus, violet scatters more, but gets filtered out. The sky is basically invisible. I'm just seeing my eyeballs' reaction to physics. And if you really want to blow their mind, tell them this. If Earth had a different atmosphere, the sky would be a completely different color. On some planets, it might be purple, green, or orange. The sky's color isn't something the sky has. It's something your eyes create when they perceive scattered light. Watch their brain explode.